Hi, I'm Anna Vasquez.
Hi, I'm Sarah Torres.
Hello, I'm Maria. Hi, I'm Grace Flores.
Hey, I'm Mario Delgado.
Hi guys, and welcome to another episode of Fun with Geology. In today's episode, we will be discussing and visiting about the famous sunken city that is located in San Pedro. We will look into how Sunken City was formed and how it looks today. Let's go!
Welcome to Sunken City!
If we make it, that'll be awesome. If we don't, Mom, I love you.
The land around the surrounding area called Point Fermin started to move in 1929 and continuously moved little by little until that made Sunken City. The landslide occurred at the southern tip of San Pedro, where a piece of the land, nearly 40,000 square feet in size, started sliding away from the cliffs into the ocean. Experts investigating the landslide said that the ground was shifting at a rate of 11 inches per day. Since the landslide in 1929, Sunken City has gone into relative obscurity and is for the most part abandoned as far as refurbishment. The land is continuously moving, although it is not as drastic as it was in the landslide in 1929. The steep cliffs and loose rocks are the reason that the Sunken City is fenced off to the public. The geographical construction of the land makes it unsafe and a potential hazard of people's safety, even for those experienced hikers.
Landslides usually occur where there are steep slopes, mainly on mountain regions. Landslides refer to a large amount of mass, rocks, and soil. The destructive landslides usually happen within time. With these type of landslides, an earthquake may occur. The primary cause of landslides have to do with gravity. Due to water uprising, most of these landslides seem to happen often. Water usually causes landslides. Because of heavy rainfall, the mud gets heavy, then it would withstand the force of gravity. Every landslide has their own way of being identified. In most cases, they are identified by the downslope and how the material falls. Homeowners think that it is acceptable to build their home on a cliff due to reasonable rent and the beautiful view, but they do not think of the consequences of when a dramatic event may occur. Without doubt, these people should not only think about their homes, but also about their lives. Human-caused landslides can be avoided by better planning of buildings and roads. Because of poorly drainage planning and the disturbance of old landslides, we often see more landslides. The vibration of heavy traffic and the removal of larger rocks affect landslides. Because the less support it has, the more weight it carries, making homes and lands collapse. Within the vibration of the city traffic, sediments seem to move out of place slowly. With time, it all becomes less dense and landslides may occur.
Because of how dangerous this location is, it is a gated area, but people still manage to climb through. Once we enter the abandoned site, we notice the pathway that looks like an old road. This could be known to be an old coast highway where homes were once located in the early 1920s. The types of rocks we see here are known to be very weak and unstable. They are made up of mudstone and shale. These types of rocks are known to be sedimentary rocks. Because they are exposed to water, it is easier for these rocks and lands to uplift and be brought down to the ocean. As you can see, we can easily pull them apart by picking them up or even sliding them with our foot, adding no type of pressure. We also see the type of soil that is all around here. It is only 2 inches of thickness, which is not a lot compared to other locations. Between these rocks, we also came upon some pipelines. Due to drillings located in the middle of the landslides, the excessive movement could have led to the causes of these dangerous movements. Which means, if another natural disaster were to occur, like a major earthquake for instance, then it would end up causing these weak and unstable lands to come crashing even more down. If you try to come down here, you would definitely need to wear non-slippery shoes because the moment you step on a loose rock, you too can end up falling down.
Another reason to the fall of the Sunken City area was erosion.
This is when the soil is slowly detached or removed from the land. The specific type of erosion that was happening in the San Pedro area was by water, so heavy rainfall and waves from the ocean were leading factors to it. Erosion caused the sediments that were removed to bury any plants and roads. Erosion can happen very slowly or rapid. This just depends on the type of soil or rock there is. In this case, there is mudstone and shale. In this part of the video, we are able to see erosion in action. As we can tell, the rock in the middle of the ocean has graffiti, which it makes me believe that the rock was once on dry land. This shows how heavy rainfall and waves can cause part of the land to drift into the ocean.
Since California is in between two tectonic plates, which impact what San Pedro has become today, the types of rocks that are lying underneath the Palos Verdes Peninsula are schist and sedimentary rocks. They have had irregular masses of basaltic volcanic rocks. Since all California is under the fault, the Palos Verdes sunken city gets many damage throughout earthquakes. The earthquakes tend to damage the land in many ways, both physically and under the surface it's located. The Palos Verdes fault zone is the most prominent and the most complicated data structure revealed by seismic reflection. The fault zone separates the folded shelf rocks primarily of Miocene and Pliocene age that occurs west of the Palos Verdes fault zone. An anticline underlies the seafloor scarp along the east side of the Palos Verdes fault zone, and the anticline dies out upward through the rock sections so that shallow rocks are barely arched. Likewise, a minor fault east of the anticline offsets deep basin rocks and extends upward through the unconformity but dies above that. All these structures indicate that throughout time near the knoll, folding and faulting focused along the Palos Verdes fault zone decreased in intensity to be replaced by regional tilting. The underlying fault lies below the depth of the penetration of our seismic reflection data. Even so, we interpret this fault to be the Palos Verdes fault.
Thank you for watching today's episode of Fun with Geology, where we got to explore and talk to you about San Pedro's sunken city. Please make sure to come back every Tuesday and Thursday at 11:30 for new episodes. If you want to know more about what we do, feel free to follow us on Instagram or Twitter at fun_geology.